next up we have Brian Childress. Brian is an accomplished technologist, having spent time building and scaling software in many highly regulated environments. He holds multiple patents for software design, speaks internationally, and is a sought-after thought leader. Brian resides in Virginia, loves to travel and explore, often bringing his family along for the adventure. And he's going to be giving a talk on simplicity, the key to software success. Give it up for Brian.
All right, good morning.
Good morning.
So I'm excited to be back in Asheville. I was here late last year with my family doing probably the most touristy thing possible. We went to see Christmas lights at the Biltmore. Absolutely beautiful if you haven't been. So I'm excited to be here because simplicity, the key to software success, is really something that's kind of near and dear to my heart. So who am I? My name is Brian Childress. I'm from Richmond, Virginia, and I've been working in software for many, many years. I also serve as a technical advisor for a number of different organizations, startups, small and medium businesses. And a lot of what my work here is what I'm going to be sharing with you today. But to get us started, I like to do more interactive sessions. I know hopefully we have enough coffee flowing through our veins now. So since we're all technologists, I'd like for us to build something together. So I'm going to share a couple options, and I just want you to raise your hand, hoot, holler, whatever feels appropriate for you, for the one that makes the most sense for you. So we're going to be building some software together real quick. First, we need an architecture. Monolith versus microservices. Where are my monolithic fans? Yeah, all right. Kind of picked that one. Any microservice folks, right? We got to build this thing to scale, so let's just go ahead and build it right the first time. All right, you're in good company. I feel like this is a gimme, but I'll give you the option anyway. Ruby. I have found some JavaScript, some Node folks out there. Yeah, a couple, no, oh, no. That was a delayed hand, all right. Databases, we've got to store our data somewhere. Relational. All right.
As long as it's Postgres.
There you go, that's my man. Non-relational, Mongo, oh, wow, it's the first time I've ever had none for non-relational. We need to get our data out of the database somehow. REST, plain old REST, for the win, works every time, most of the time. Anyone using GraphQL? Anyone excited about using GraphQL or using it in production? A few folks? Very cool. Thank you all. We just built an amazing application. But as we went through that, I'm curious if any of you were asking why? Or what is this for? Or my favorite answer to every technical question I'm asked, well, it kind of depends. Right? As we were going through, we were picking the technologies that we're most interested in, we're most familiar with, that we're really excited about. And I'd love to share with you that we just built the world's most highly scalable, globally distributed to-do list application, right? Some of the decisions we make may not be the right thing for the applications for the software that we're building. Because at the end of the day, software is just a tool that we use to solve problems. For many of us, we focus so much on the technology and so much on the software that we forget about the problems that we're actually paid to solve. According to my extensive Google research earlier this morning, about 70% of software projects fail. 7 in 10 projects fail. Has anyone ever worked on a software application that never made it to production? This is a safe space. We can all be true. 7 in 10, that's disheartening. As an engineer, we pour blood, sweat, and tears into the software that we're building to see it just never get into production. Or even worse, it gets into production to be quickly sunset after. So there's a few reasons that I've found that a lot of software projects fail. Oftentimes, it's unclear requirements. The business has an idea that they want to solve the next big problem or build the next great thing, but we're not really clear about what that means and what is the end goal for what we're building. We could have just misaligned goals, not just the requirements, but the goals themselves. And so as technologists, we want to play with the latest and greatest technology because that's what we're in control of. But we're not aligned with what the business needs. And then finally, one of my favorite things is that the technology is just too darn complex. And many times this is of our own making. We bring in technology that we don't need, which increases the complexity, which makes it more difficult, which can lead to software projects failing. One of my favorite software architects out there is Neil Ford. Has anyone ever run across Neil Ford? He's got a friend, Mark Richards. Okay. I would encourage you to look them up. They've got some great books out there. But this is one of the quotes that I like from them the most, or from Neil specifically. Developers are drawn to complexity like moths to a flame, often with the same result. Technology itself is already complex, so why do we, as technologists, encourage or get excited about making it even more complex? Oftentimes, it's because there's new technologies out there. There's new frameworks, there's new libraries, there's new languages that are coming out, and we want to use them. And because we can't use them in our side projects, we bring them into the organizations that we work with. Who here is guilty of this? Has brought in new technologies because they're bored? Yeah? Tired of building the same CRUD application, talking to the same database that has the same database tables. So we get bored and we bring in new technologies. Again, I mentioned that we're in a safe space, and I want to make sure that everyone here is honest. Who here has ever suggested or brought in a technology because they thought it would look good on a resume? Yep, I'm guilty. And I still feel bad for those organizations dealing with that technology years later because I wanted to put that technology on my resume so that I could say that I put it into production because I knew that I was on my way out into a new organization. These are the things that ultimately hurt the business. When we take our own needs, our own desires, and bring in complexity into the software that we build, it ultimately hurts the business. So how do we get around this? How do we not only stay excited about the things that we're working on, the technologies that we're using, and also serve the business needs? One of the ways I like to do this, I feel like this is an offensive emoji, but is the rule of one. So let me explain. The rule of one says, okay, for a new project or a new large initiative that we might have, we get to change one thing. We get to change one framework, one library, one architecture. We're not going to change all of them for the new application. We're not going to bring in the leading or the bleeding edge technology unless we absolutely need it as a differentiator for the applications that we build. We get to change one thing. Because as a team, everyone on that team likely has to learn that new one thing. If I change the architecture and a back-end runtime or a database, that's a lot for an entire team to have to understand. And that leads to, ultimately, potential for a failed project. I want to ask you if you've ever heard this buzzword, or more likely, been asked to make sure that your application can serve data in real time. Has anyone ever, right? As engineers, we love this term, real time, right? Because for us, the wheels start turning and we start to look at all the capabilities that AWS or some of these other platforms can provide for us to be able to get globally distributed data in near real time to all of our customers anywhere, wherever they exist. But oftentimes it's not actually our definition of real time, and what the business's definition of real time is completely different. And if, as technologists, we don't clarify what the business is actually looking for, we're going to create a system so complex that it's going to be so difficult for us to continue to grow just because we solved for the wrong problem. Usually real time for most businesses means, hey, I want some updated data on the dashboard when I log in at 8 a.m. with my first cup of coffee. For us, we're thinking about millisecond distributed data with eventual consistency. I want to share with you a case study of a group that I worked with probably 2022 now. This was a really interesting project. A company reached out to me on LinkedIn, and they had a project where they needed to build an application. They already had been working for about 6 months on the application, and things just were not going well. They had, at the time, we had teams or team members across about 6 different time zones. I was the easternmost person, so most of the time when I was starting my day, the team was either ending their day or had already were heading to bed. So we had a big distribution problem. Other really interesting thing was I had about 3 weeks to turn the project around, and if I didn't, the project was a complete waste because we had a real, actual deadline. Most of the deadlines that we have are kind of made up, if we're honest with ourselves, right? It's some stakeholder, some CEO that says, hey, we'd love to get this application out in Q2 of next year. What was interesting about this project, and one that I haven't had in any other project, was it had a real, actual deadline. To give you a sense of the timeline, in August of 22, development began. Somebody had an idea, commissioned the project, and started to spend money on finding development resources. I joined in, I guess my timeline's wrong, in January of 23 with the project where it was, and we had to deliver by February of 23. Gives me about 3 weeks. What was really interesting with this particular project was when I came in, it looked like somebody had gone down the AWS menu and just selected everything that looked cool. There was, Kinesis, DynamoDB, tons of machine learning models. To give you a sense of the project itself, basically we were ingesting public data. We were using some NLP machine learning models to determine sentiment, storing that data in a database, sharing it on a dashboard. At the end of the day, we had, 8, 10, 12 users on the platform. They were high-level users. They wanted the information, but we certainly didn't need that level of complexity. So for me, my first step was to come in and understand what was the problem that we really actually had to solve. And my first solution was to re-architect and rip out about 80% of what we just did not need. Unfortunately for the team, they had received guidance from a technical advisor who worked at one of the big tech companies and said, hey, you need this. This is the architecture that you need, and didn't really take into consideration the number of users, the type of data that was being stored, or the timeline and the skills from the development team. I pulled out about 80% of those technologies, and within a few days, we had completely re-architected the solution, and now we had data flowing end to end. The team wasn't able to do that for 6 months prior. Now that data was flowing end to end, we were able to then continue to grow and to scale, and in a couple weeks, I had more developers working in more time zones, contributing more code to the platform, and ultimately, we were able to hit that February 2023 deadline. Buzzword number 2, by far my favorite. I am currently working on a book around this. Who here has ever been asked to make sure that the systems that they're designing and building is scalable? Scalable, right? We all have our own definitions of scalable. What the heck does that even mean? Scalable can mean so many different things in different contexts. We hear scalable in a lot of business conversations now, not even related to technology, but how do we make processes and systems within the organization scalable? So I like to think about scalability in 3 different ways. The first is users. I need to be able to add more users to the system. And when I add more users, I want to make sure that performance is the same or better as we add more users to the system. From my perspective, in my opinion, I feel like this is largely a solved problem. We've got a lot of examples, a lot of different architectures that we can draw upon to solve this particular problem. Now, the two other areas that I think are much more difficult for us to solve are how can we add more features to the applications and the software that we build? And then finally, how can we add more developers to the teams that are building the features that are serving our users? Lots of clicking going on. All right, scaling users. So typically when we think about scaling users, we're thinking about how do I add more compute? How do I add things like more database capacity or the ability to process more events? As our users are becoming more distributed, this becomes a really interesting engineering problem about getting our functionality, getting the data closer to that particular user so that their performance, their experience continues to improve. And again, I feel like this is largely a solved problem. We've got a lot to draw on. When we start to think about scaling features, the idea of scalability becomes more interesting. We need to make sure that the features themselves align to the business. What I've seen happen a lot is that the features that we develop, the language, the terminology that we use in the features don't necessarily align with the business. What we call something on the technology side in the database table is completely different from what the business calls it. And so what we end up having to do is to make some sort of translation between what the heck is it on the technology side? Oh, in the business it's called this thing or it's called that. When we think about scaling features as well, this is where I really look to maintainability and modularity. There we go. So case study number 2. This was an interesting one. I worked with a health tech startup who had raised their Series B funding. I want to say this was in 23 as well. They had raised about $17 million, and part of that raise was to be able to grow the team. They had a fairly standard stack, right? A lot of fans here. Rails, Postgres, AWS. Very, very simple. It was a monolithic application. They did well on their infrastructure. They had exactly what they needed to be able to support the load that they had. The one interesting thing about this particular company was that it took about 6 months for a senior Rails developer to be able to confidently put code into the production code base. 6 months. Has anyone ever spent 6 months of onboarding to try and get code into the, I'm sorry. Yeah. That's a long time. As an engineer, it gets pretty disheartening when you can't confidently commit to a production code base for 6 months. For me, I like to see that time far, far less. I like to see developers being able to spin up their local environment in an hour and a half with some support from maybe someone else on the team. I like to see people being able to commit code to a production code base within a day, week at most. 6 months to be able to put code into the code base, that was pretty tough for this particular team. And ultimately, it led to a lot of attrition on the team and a lot of frustration. There was a lot of finger pointing going on, and it was really unfortunate. And so what I came in to do was to try and help them to understand how did we get to this point and how can we kind of back our way out of it. What ended up happening was that the product team and the technical team just weren't working together. Product was making decisions and the technical team was just implementing them. What ended up happening, or what the code base ultimately looked like, was something like this. Because it was a healthcare application, it was configuration driven, and basically what happened was the product was designed in such a way that almost every user had their own version of the application. Because so many different things were configurable, based on so many number of different variables, the state they lived in, their healthcare provider, all sorts of different things. And this really led to a lot of issues, not only on the technical side with the ability to add developers to the platform or to the development team, but also the ability for customer service to support their customers. Because the customer service team said, I have no idea what your version of our application actually looks like. We're not logging, and we don't store your configuration in a way that I can confidently replicate what the application looks like for you. So good luck. And it led to a lot of issues from customer service, from product, and from the development perspective. This leads me to the third area that I think about scaling, and this is the ability for us to scale developers. And I think this is a really interesting one that is often neglected, right? As we start on brand new applications, it might be a couple of us developers. We spin up a GitHub, we start, working through things, and what works on our machine just kind of works. But we don't think about what does it mean for us to bring on a new developer? What is it like to download the code repository and run a simple set of scripts to be able to set up the application? If we have a complex architecture, multiple microservices or multiple databases that I have to run, what's involved in that? What is required for me to be able to do that? A lot of times we say, oh, we'll look at the documentation. The code is self-documenting, but is it really? Is it easy for me to understand where things are and how things are constructed? For me, I have a couple rules around this. One is the code should be readable and understandable by a junior engineer. Might not be able to write or to architect it in that way, but a junior engineer should be able to come into a code base and understand what a set of functionality is doing. A brand new engineer should be able to come into the code base, and once they understand where things are placed, what we call, maybe the users or the profiles, once they understand where those things are, the code is structured in such a way that it looks like it's written by one engineer, even though a team of 10 or 100 engineers may be contributing to that code base. It takes a lot of concerted effort to be able to do that. But when the code looks like it was written by one engineer, it's a heck of a lot easier for me to come in and start to navigate and understand. I don't have to understand not only what the heck the code is doing and what the business is doing. It's more easy for me to just understand, okay, what is the business problem that I'm solving here? Onboarding is a big thing, and also technology is a big thing. I've had to rewrite entire applications just because we were not able to hire enough qualified developers to work on the application. We pick the greatest, highest concurrency software or run times, and I can't find anybody to work on it. And ultimately, this is a huge cost to the business. And as technologists, it's our job, it's our responsibility to guide the business to pick the technologies, to pick the architectures that ultimately will support the business in the long run. So I want to share one more case study with you, and this is the one that I worked on most recently. This was an organization that's been around for about 10 years, has an offshore development team based in Eastern and Central Europe, and their goal was they wanted to scale the number of developers, and they wanted to say, I want to add a developer from anywhere in the world. I want to just add a developer who can start to write code and contribute to our application because we want to reduce our costs from one particular team, or we want to bring in certain expertise. And so this was a really interesting challenge. It should be something as simple as, oh, well, just add them to the GitHub and they can start committing code. What we found, though, was that our documentation probably wasn't in the same language. Our passwords, credentials, they were all stored in plain text, available to anyone who was added to the documentation site. And so this was a big, big security risk for us, and we needed to bring that in, get that under control before I could just say, hey, brand new developer somewhere in the world, let me add you to the application to start contributing. And what I think is really interesting about the desire to scale the number of developers is it really starts to pressure test our systems, our communication, our documentation, because without those things in place, it really starts to break down really, really quickly as we add more engineers. And that engineer could be sitting in the desk next to us. Really, not many of us are in offices these days, or they could be halfway around the world in 12 hours in a different time zone. All right, so just to kind of wrap up here, I want for all of us to remember that at the end of the day, software is just a tool that we use to solve business problems. It's already complex enough, so we're better off by not adding additional complexity on there just because we're either bored, we're trying to pad our resumes, or we get really excited about some new technology that we see a speaker talk about at some conference somewhere. I always encourage my teams to focus on what is the problem. How simple can we make the problem to understand across the organization, across the development team? If anyone ever says, well, problem's too complex, you're just not going to understand it, then we don't understand the problem well enough, and I always push back on that. So I encourage all of us to really focus on what is the simplest way that we can describe the problem, and then we go from there. I don't know if we have time, but I'm open to questions if there are any. Yeah, in the back.
So I was just curious, say you're on the development team and a technical advisor comes in, similar to the example that you provided, where this technical advisor who works for the company that they were promoting in a way to these developers said, hey, you're going to need this. This is really important for what you're developing. How is it that people on those teams, those development teams, can kind of find themselves with the knowledge to be able to refute that kind of suggestion if they deem that either A, that's way too complex for what they want? How is that you recommend these development teams do these research, especially when you're kind of hiring this advisor in?
That's a really, really good question. And I think it's kind of two parts. Hopefully the advisor is someone that's willing to receive that pushback and answer those questions. But from a development team perspective, what I found is you've got somebody from a big name tech company coming in. They've got a big VP of engineering title. And I'm a developer. How can I push back on this person who's an expert with 20 years of experience in the industry? I like to go back to simple, and I always encourage us to ask the why question. And I typically like to ask it 5 times. So you said that we need DynamoDB. Why do we need that? Why do we need that? Why do we need that? And really, it has to come down to, okay, well, what purpose is DynamoDB going to serve for us if that's the technology that you're suggesting? It should be a conversation back and forth, and there should be some engagement. Now, it's important for us as the development team, too, to really bring our knowledge and our experience, and it's not just, yeah, I don't really like that, like you're telling me we got to host this thing in Azure. I prefer GCP. Like, there has to be a legitimate reason. So it's important for us as the development team to bring that information as well. But really, it should be a conversation. And I would encourage you to really stand up if you're intimidated by somebody with those kinds of accolades coming in, to really say, hey, I don't think that this is right for the organization. And it may be okay to go around the technical advisor and say, hey, this person isn't guiding us in the right way, and these are the reasons why, but always supporting that with evidence and data. Good question. Yeah, absolutely. So coming into a new organization, or it may not even be in a new organization, but what are ways that we can keep documentation up to date so that it is leveraged by everyone in the organization? Is that a fair summary? So there's a couple things that come to mind. First is, where do we store the documentation? And for me, that needs to be closest to where it's going to be used. And so if I'm documenting a function, I might want to understand why we're doing it this way. Not necessarily how. The code should be self-documenting enough that it's like, okay, I can see what it's doing, but why did we do this? Oh, well, because we ran into this bug with this date, or here's the GitHub issue related to it. So it might be at the code level, within a code file. It might be in a README within the code repository, or it might be in a shared documentation repository. And I don't like to have too many places that it could exist, so it's more like where is this information going to be consumed by what audience, right? Is it by the technical team, by the broader business? Then I might want to focus there. One thing I've also found too, as far as documentation, not necessarily specifically, but the communication around things, is we have to communicate it the same message in multiple ways to multiple different people at multiple different times. And basically what I mean by that is, yeah, we might be a very documentation, like written documentation heavy organization, but if there's something that I want to share, I might record a Loom video, attach it to the documentation, and share it in a Slack channel. I might also create a PowerPoint presentation and share that with the team, walk through that in a Loom video as well. Because not all of us consume information in the same way at the same time. So we have to do it in multiple different ways. Does that help? Cool. Yeah.
So what did you end up having to do with case study number 2, the configuration explosion? What would you like to have done if you weren't able to do it?
So the first thing was to understand what the configuration looked like. So being able to support the customer service team, because that's where we were immediately losing money. And so it was just starting to put like logging in place, like, hey, we need a way to store this particular configuration so that I can basically replicate it from a customer support standpoint. And then from there, we were able to then like start to reduce it and say, okay, this configuration, we don't need that granular of the ability. So like basically what's the 80% of functionality that we need? We're gonna make that part configurable, and the rest we just have to say, hey, sorry product team, this is what it's gonna look like. These are the confines that we have to work within. But it was ultimately, it started with a really difficult conversation between the product manager or owner, who basically got everything that they had always wanted for the last 4 or 5 years, to say, hey, we're not going to operate that same way anymore. And that required, there was a new CTO that came in, and I think a new VP or engineering manager that came in to have that tough conversation. Yep, go. Yeah, so I'll try and answer your question maybe a little bit more broadly. Like, how do you argue the trade-offs? For me, it comes down to who is my audience. So understanding what that product owner cares about. They may care about something different than like a CEO might care about, right? It could be revenue versus the user experience of the product. I always like to focus on what do they care about, what information do they have, and support it with the information that we have, and what it, like tying it, ultimately I always have to tie it back to what is the cost, right? Not only time, development time, and revenue or potential loss of revenue. I always have to tie it back to something that it's like, okay, if you're gonna say that this is gonna take 6 months, it's like, well, what does 6 months mean? Is it 6 months for one developer part-time or an entire development team? And what does that impact? But it always comes down to what do they care about, not what I care about. What I care about, I have to translate into their language. Yeah. Yeah, no, that's a great point. And we talk about tech debt a lot, and we, as engineers, we tend to tie everything to tech debt, because if we call it tech debt, maybe we'll get it on a backlog, maybe we'll get the chance to resolve it in the future. But for tech debt, if I just say we need to like squash these bugs, okay, cool. Like, who is that impacting? As a developer, like it's impacting my developer experience and it makes me grumpy every day, or is it actually impacting users? And this is where we can tie that back to it's impacting this many users, and those users, are churning at this rate or whatever. So it's usually tying it back to other data that we may not even have, but if we can collect that data to say, hey, this issue is actually really impacting us, and I can tie it to an actual dollar value to say, hey, this is worth us spending, a week of a developer's time to gain or not lose this $100,000 of potential revenue. Those are just business terms that make sense, which is really where I think the term tech debt really kind of came in, was because we can tie it back to some sort of financial mindset. Yeah. Awesome. Yeah. That's a really good question. So when do we think about bringing in a technology that might be new and shiny? When does it become mature enough? A couple rules of thumb there. I tend towards boring technologies, right? The Postgres, the Rails, the applications or the software that we have seen large organizations scale and serve millions and billions of users. If an organization can do that, then I can trust it. I also know there's a decent ecosystem of developers that I can hire for, and that's always a big thing that I focus on. If it's leading edge or bleeding edge, it has to be a differentiator for us in what we're doing and what we're trying to solve. If it's just a new, cool, shiny thing, then it's probably not the best thing to pull into our ecosystem. As much as we'd like to do it, we've seen a lot of startups go away that we might have adopted their particular technology, and now our business is at risk. And so it sucks for us as developers to not be able to pull in those new, fun, exciting technologies, but it is a business risk that we have to consider. When I think about boring technologies too, it's like, is there a conference for it? You know, if there's a conference that's in its second or third year, likely it's got a large enough community around it to support it that there's enough Stack Overflow or, whatever, Chat GPT answers for it. I've certainly adopted frameworks where it's like, I can't find a Stack Overflow answer for the problem I'm having because the framework is so new that I can't solve my own problem. And that's a really difficult place to be. Cool.
In terms of keeping things simple, when do you choose to roll your own solution to a problem versus bringing in a debt?
If it's a differentiator, if it's the thing that we're building, if my company is an authentication company, I might consider rolling my own. If my company is not an authentication company, I would avoid it. Feature flagging, any of those types of things where I can easily pay $19 a month or $1,900 a month for something, then I will. But again, I'm going to be looking at how adopted is this particular technology or this company before I bring them into my organization. Is it something that has someone else used them and had success with them before I bring them in? Like, let them, figure it out first before I do. Yeah, good question. Cool. Thank you all.